How do North Koreans survive winter with almost no gas or electricity? Imagine living where power outages are routine and temperatures drop well below freezing. Apartments go dark, heaters stay cold, yet families endure year after year. What ancient survival tricks kept them warm when the cold tried to break them? For thousands of years, Koreans survived freezing winters by heating the ground beneath their feet. Ondol, also called gudul, is an underfloor heating system that predates modern boilers by centuries. In North Korea, where power outages are routine and fuel is scarce, ondol remains one of the most reliable ways to stay warm without gas or electricity. The system works by guiding heat and smoke from a fire through stone channels beneath the floor. A fire is lit in an outdoor or semi-outdoor furnace connected to a kitchen stove. The hot air travels horizontally under thick stone slabs before exiting through a chimney on the far side of the house. As the smoke moves, the stones absorb heat and slowly release it upward into the living space. This process creates deep, lasting warmth. Even after the fire goes out, the floor continues radiating heat for hours. In winter, families often light the stove once or twice a day and rely on the stored warmth through the night. The stone floor becomes both heater and bed, perfectly suited to a floor-based lifestyle. Homes built with ondol are arranged around this system. Living, eating, and sleeping all happen on the floor. Thick quilts and mats trap warmth close to the body, while walls and ceilings can remain cold without affecting comfort. The heat stays where people need it most. Ondol is also efficient with fuel. It uses the same fire for cooking and heating, reducing waste. Almost anything that burns can be used, including wood, coal dust, corn husks, and agricultural scraps. In rural and poorer areas, this flexibility is essential. When fuel is limited, ondol still functions. In apartment buildings, especially those built during the socialist era, ondol systems were adapted to serve multiple units. Heat from a central source passes through several floors before escaping, warming many homes at once. These systems often struggle today due to maintenance issues, yet the underlying design still proves resilient. Ondol reflects a harsh reality. When electricity fails and modern heating disappears, heat stored in stone keeps families alive. It turns fire, earth, and patience into survival. In North Korea's long winters, warmth does not come from switches or wires. It rises slowly from the ground, shaped by tradition and necessity. In North Korea, warmth in winter often begins with a dark disk of compressed coal. These yantan briquettes are cheap and easy to stack along stairwells or in small sheds. For many households with limited access to gas or steady electricity, they remain the main fuel for both heating and cooking. A yantan briquette looks simple. It is a round block of coal dust mixed with binding materials pressed into a cylinder with many small vertical holes. These holes are the key. They control airflow so the coal burns slowly from the inside out. One briquette can smolder for hours, providing long, even heat to a stove or all-ondol floor without constant tending. Families often plan their winter around how many briquettes they can secure. Some buy them through official channels, others obtain them through informal markets or barter. They stack the fuel to keep it dry. A wet briquette smokes heavily and wastes heat. A dry one burns cleaner and hotter. Inside small homes, yantan fires are usually placed in a chamber beneath a cooking surface or at the entrance to an ondol flue. The heat travels along channels under the floor or up into pots and kettles. Ash is removed regularly and stored in metal buckets. It can later be used for simple insulation around pipes or walls. Using yantan safely requires constant awareness. Poor ventilation can lead to carbon monoxide buildup. In harsh conditions, people sometimes block windows to keep cold air out, which raises the risk even more. Many families develop routines. They crack a window at certain times, check for unusual smells, and teach children to stay away from hot surfaces. The daily work around yantan becomes part of winter life. People haul stacks, brush soot from clothes, and sweep black dust from floors inside and out. Despite the dangers, coal briquettes continue to dominate winter life because they are reliable. Blackened walls and soot-stained ceilings mark years of use. In neighborhoods where power flickers and gas is scarce, the steady glow of a yantan stove often decides whether a room feels deadly cold or barely survivable. In North Korean cities, many concrete apartment blocks rely on modern versions of the traditional ondol floor. Instead of wood and stone in a rural cottage, heat now moves through pipes and channels cast into cement slabs. The idea has not changed. Warm the floor, and the people will endure the cold. Centralized boiler rooms often feed these systems. Hot water or steam travels through a network of pipes that run beneath apartments, warming the floors from below. In theory, this creates stable, efficient heating that reaches every unit in a building. In practice, the experience depends heavily on fuel supply, maintenance, and local conditions. When fuel is available and the system works, residents feel a gentle rise of warmth through the soles of their feet. A thin mattress on the floor becomes a comfortable bed. Children play on the heated surface. Older people sit or lie directly on blankets spread over the warm concrete. The air may stay cool, but the contact with the floor keeps bodies from freezing. Our problems begin when cold deliveries are delayed or when equipment fails. Some apartments receive full heat, others remain lukewarm. Residents respond with improvisation. They add extra blankets on the floor, seal windows with plastic, and sometimes burn small stoves in corners to supplement the weak ondol. Because many North Korean homes revolve around floor-based living, these systems shape daily life. Furniture stays low. People cook, eat, and sleep on mats that rest on the heated surface. When the heat is strong, it creates a sense of refuge from the harsh weather outside. When it is weak, the cold seeps upward, turning every activity into a test of endurance. Maintenance crews do what they can with limited tools. Leaks, air pockets, and broken valves are common issues. Residents may not know where the boiler stands or how much fuel remains. They judge the situation with their feet. If the floor cools, they know something has gone wrong. Apartment-installed ondol represents both progress and fragility in North Korean heating. It extends an old idea into modern buildings, but its success always depends on resources that are never guaranteed. In many parts of North Korea, especially in older rural homes, heating often comes from simple, direct fire stoves built into the structure of the house. These units rely on a firebox made of brick or stone. Once lit, the heat radiates outward into the room, giving immediate warmth in a space that might otherwise sit at freezing temperatures. Because electricity is unreliable and fuel is expensive, these fireplaces serve as dependable sources of heat during long winter months. The design focuses on durability and efficiency. A small opening is used to feed fuel into the firebox, while the chimney draws smoke away and reduces the risk of inhalation. Farmers and villagers gather sticks, branches, and crop residues to burn. In more severe winters, anything that can catch fire becomes useful, including dried corn husks or small bundles of brushwood. The heat produced does not fill the entire home, but it creates a warm zone where families gather to cook, eat, and sleep. These stoves often become the heart of the house. Meals simmer on top of them in metal pots, while kettles sit nearby to warm water. Children sit close during study time, and elders rest near the heat to protect their joints from the cold. The flame glows steadily behind the firebox door, a small but powerful shield against outside temperatures that can sink far below freezing. Maintenance is simple. Ashes are removed each morning, the firebox is cleaned, and new fuel is prepared for the day. Because winters are long, households learn to stretch every piece of available material. Even small sticks are gathered and dried months before the cold arrives. This habit forms a natural cycle of preparation that shapes daily life. Direct heat fireplaces may look humble, but they carry a heavy responsibility. They provide warmth, a cooking surface, and a central place for family life. Their steady glow offers security during nights that would otherwise be dangerously cold. The traditional Korean agung-gi and gamasot system is one of the most efficient ways to combine cooking and heating in a single structure. In many North Korean homes, especially in the countryside, this method remains essential. It begins with a firebox built low into the floor. Above it sits a large iron pot called a gamasot, used for boiling rice, stewing vegetables, or preparing seasonal dishes. The fire that cooks the meal continues through channels beneath the floor, heating the home from below. This integrated approach saves fuel and time. A single flame achieves two goals at once. As the family cooks breakfast or dinner, the heat spreads slowly through the living space. The stone and clay beneath the floor absorb the warmth and release it gradually over several hours. Even after the fire dies, the floor stays warm long into the night. This slow release is vital in a region where nights can become dangerously cold and electricity cannot be relied upon. The agongi requires attention and skill. Fuel is arranged in a pattern that burns evenly. The pot above must be managed carefully since too much heat can scorch food, while too little can leave it undercooked. The movement of smoke through the heating channels also needs to remain unobstructed. Families learn these habits early. Children watch their parents tend the fire and eventually take on the task themselves. The system also influences the rhythm of daily life. People eat, talk, and rest on the warm floor. Bedding is spread out in the heated area at night. During colder months, many families spend most of their time in one main room that stays warm from the agongi. This creates a natural gathering space where meals, conversations, and rest happen together. The design reflects centuries of adaptation to a harsh climate. It transforms the basic act of cooking into a reliable method of surviving winter. The soft, steady heat beneath the floor becomes a quiet companion during months when the world outside freezes solid. In North Korea, balconies are rarely decorative. In winter, they become a critical line of defense against the cold. Many apartment buildings include narrow concrete balconies that were never meant for comfort. Over time, residents transform these exposed spaces into improvised heat buffers using sheets of vinyl, plastic, or salvaged window panels. The idea is simple and practical. By enclosing the balcony, residents create an extra air pocket between the outside world and the living space. Cold wind no longer hits the apartment wall directly. Instead, it slows, settles, and warms slightly before reaching the interior. Even a few degrees of difference matters when temperatures stay below freezing for months. Vinyl sheets are popular because they are cheap, lightweight, and easy to attach. People stretch them across metal railings, sealing edges with tape, wire, or strips of fabric. Some use old greenhouse plastic or translucent industrial wrapping. The result looks uneven and temporary, but it blocks wind remarkably well. Sunlight still passes through during the day, warming the enclosed space naturally. Once sealed, the balcony takes on new functions. It becomes a storage area for coal briquettes, firewood, or biomass fuel, keeping them dry and closer to indoor warmth. In some homes, residents place makeshift boilers or hot water containers inside the enclosed balcony, allowing heat to accumulate before entering the apartment. Clothing, bedding, and food also benefit from the slightly warmer air. This enclosed space reduces heat loss from the main apartment, especially in buildings with poorly insulated concrete walls. When ondol floors are heated inside, less warmth escapes through the balcony-facing wall. At night, residents often close interior doors or hang blankets between rooms to further trap heat. Maintenance is constant. Vinyl tears in strong wind and must be replaced or patched. Condensation builds up and freezes, so people wipe down surfaces daily to prevent cracking. These routines become part of winter life, practiced with quiet discipline. Vinyl balcony enclosures reveal how North Koreans adapt architecture to survival. Without access to reliable energy, they reshape existing spaces instead of building new ones. The balcony, once useless in winter, turns into a shield against cold, a storage zone, and a passive heat trap. It is another example of how scarcity forces creativity, turning fragile plastic into a barrier between life and freezing air. When formal insulation is unavailable, North Koreans turn to what they have. Foam scraps, ash, cloth, and paper become tools for holding back the cold. Apartments built with concrete panels and thin windows leak heat quickly, especially during extended outages. DIY insulation becomes a necessary skill rather than a hobby. One common method involves lining walls with salvaged foam. Packaging foam from goods deliveries is cut into panels and wedged behind furniture or fixed to walls using tape or homemade paste. These panels trap air, slowing heat loss from the room. Windows receive similar treatment. Foam strips, folded cloth, or cardboard are pressed into gaps around frames where cold air seeps in. Ash plays a different role. Collected from coal briquettes or wood fires, it is stored and reused as insulating filler. Families pour dry ash into cloth bags or between double wall layers, then place them along exterior walls or under bedding. Ash traps air well when dry and helps stabilize temperature near the floor, where people sit and sleep. Doorways are another focus. Thick curtains made from layered clothing or blankets are hung to divide rooms and reduce airflow. These barriers create smaller, heated zones within an apartment. By closing off unused spaces, families concentrate warmth where they live most, often in a single room during winter. Floor insulation matters deeply because daily life happens at ground level. Foam pieces, cardboard sheets, and layered mats go beneath blankets and quilts. Even thin materials add protection against cold concrete that would otherwise draw heat from the body throughout the night. None of these methods look refined, but they are effective. Each layer adds resistance to cold, even if only slightly. Combined, they slow heat loss enough to make limited fuel last longer. DIY insulation reflects resilience shaped by necessity. When winter is relentless and resources are scarce, survival depends on how well a home can hold onto every bit of warmth it receives. Winter survival in North Korea often depends on how long heat can be held once it is created. With fuel scarce and power unreliable, households rely on thermal mass to store warmth and release it slowly. Thick materials become silent heaters, absorbing heat when fires burn and giving it back through the night. Traditional homes use stone, clay, and concrete as allies, so floors, walls, and platforms are built heavy on purpose. When the ondol system sends hot air beneath the floor, those stones soak up energy for hours. Even after the fire goes out, the floor stays warm enough to sleep on. This stored heat becomes vital during blackouts or fuel shortages. Apartments use the same idea in different form. Concrete slabs beneath flooring act as massive heat batteries. When coal briquettes burn during the evening, the structure absorbs warmth. Overnight, the building releases it slowly into rooms. Families plan heating times carefully, often burning fuel once per day and relying on retained heat afterward. Furniture placement follows this logic. Beds stay low, often directly on warmed floors. Thick mats and quilts reduce heat loss. Walls closest to heating channels become favored sleeping spots. Every habit adapts to keep warmth close to the body. Even cooking plays a role. Hot water stored in metal containers adds warmth to the room for hours. Pots are left covered to preserve heat. Bricks heated by stoves are wrapped in cloth and placed near sleeping areas. These simple techniques stretch a short fire into an entire night of comfort. Thermal mass also increases safety. Fires can be extinguished earlier, reducing smoke and carbon risk while warmth remains. This balance matters in crowded apartments and poorly ventilated spaces. The principle is simple. Heat is precious, so it must be captured, slowed, and reused. Concrete, stone, and clay become tools of survival. In homes where fuel cannot be wasted, walls and floors quietly take over the job of heating long after flames disappear. In North Korean apartment blocks, balconies often become improvised lifelines during winter. Originally built for storage or drying laundry, these enclosed spaces are transformed into heating systems when regular infrastructure fails. Creativity replaces convenience, and necessity drives every design choice. Many families convert balconies into sealed heating zones using plastic sheets, wood panels, or scavenged windows. Inside, they install small metal drums or welded tanks filled with water. A pipe connects the container to a simple stove or coal burner. As the fire heats the water, warmth radiates into nearby rooms through shared walls and floors. These boilers are built by hand. Old oil drums, scrap piping, and repurposed radiators form the core. The setup varies by household, but the goal is consistent. Store heat and water, release it slowly, and extend warmth beyond active burning time. Once heated, the water stays warm for hours, acting as thermal storage. Balconies provide safer placement for fire. Smoke exits through cracked windows or improvised vents. Families monitor flames constantly, adjusting airflow to avoid rapid burning. The system demands attention and experience. A mistake can mean leaks, smoke buildup, or worse. Heat from balcony boilers spreads inward. Adjacent rooms warm first, especially floors and walls that share concrete. Families rearrange living spaces so daily activities stay near the warmest zones. Children sleep closest to heat sources during the coldest weeks. These systems also double for hot water. Heated tanks supply washing water, reducing the need for additional fuel. In winter, this matters as much as air temperature. The practice spreads through shared knowledge. Neighbors teach neighbors. Designs improve over time. Everyone understands the risks, yet the alternative is freezing. Makeshift balcony boilers show how people adapt buildings never intended for survival heating. With limited fuel and frequent outages, warmth becomes something engineered by hand. In these narrow spaces, water, fire, and concrete combine to keep families alive through nights well below freezing. Warmth in North Korea often begins with the body itself. When fuel runs low and fires fade, people rely on clothing and bedding designed to trap heat with remarkable efficiency. Nubi, the traditional quilted fabric, is central to this strategy. It consists of layers of cloth stitched tightly together in straight or geometric patterns. The stitching creates small pockets of air that act as insulation. This simple method keeps heat close to the skin, turning fabric into a shield against freezing nights. Families prepare for winter by adding thick Nubi blankets to their homes. These quilts are heavy, dense, and built to last for years. They are placed on beds, folded over sleeping mats, and draped around shoulders during meals. Children often sleep beneath several layers, creating a cocoon of warmth even when the room temperature drops near freezing. The weight of the quilts holds heat in place, turning personal space into a small microclimate. The floor-based lifestyle common in Korean households enhances this effect. People sit, eat, and sleep on the warmest part of the home. Even when heating systems are weak, the floor retains a little warmth from daytime cooking or the residual heat of an ondol channel. By staying low to the ground, families take advantage of natural heat that collects there. Mats, cushions, and quilts stack easily, forming layers that help trap warmth. Nubi clothing extends this warmth beyond the bedroom. Quilted jackets, pants, and vests keep body heat contained during outdoor chores or market trips. The fabric is breathable, yet it prevents warmth from escaping too quickly. In rural regions, parents often pass down heavy quilted garments to children, creating a cycle of winter preparation that depends more on skill and tradition than on manufactured goods. This combination of heavy quilting and floor-based living reflects a culture shaped by hard winters and limited energy supply. It emphasizes endurance, resourcefulness, and the ability to create comfort with simple materials. At night, when fires burn low and darkness settles over towns and villages, Nubi becomes the last line of defense against the cold. It protects families through long hours, turning cold rooms into survivable spaces. Heat in North Korea often comes from whatever the land provides. When coal is scarce and electricity unreliable, families turn to biomass and agricultural waste to keep homes warm. Corn stalks, rice husks, dry grass, wood scraps, and even bundles of weeds become essential winter fuel. Nothing that can burn is discarded without thought. Everything has a potential value once the temperature begins to fall. Collected materials are dried throughout the year. Farmers gather stalks and husks after harvest, tying them into bundles that can be stored in sheds or stacked behind homes. In the countryside, families keep piles of twigs, roots, and branches gathered from hillsides. The goal is simple: build a reserve of natural fuel that can survive months of cold and shortages. Even households in apartments keep small bundles on balconies or stairwells in preparation for winter. Burning biomass requires skill. These materials burn quickly and produce uneven heat. To make the fire last, families mix fuel types and feed the flames slowly. Rice husks create steady embers, corn stalks flare quickly, and warm pots fast. Wood scraps hold heat longer than grass or weeds. By combining them carefully, people control the heat enough to warm rooms or boil water. This blending of fuels is a learned technique passed from elders to younger generations. Biomass fires often support multiple tasks at once. Families cook meals over them, heat water for washing, dry damp clothes, or warm stones for later use. In rural kitchens, fires are built inside small stoves that direct heat under a cooking pot while letting warmth seep into the room. Smoke escapes through chimneys or roof vents. In poorer homes, ventilation is minimal, turning winter cooking into a smoky, persistent chore. Despite its challenges, burning biomass remains a practical survival method. It requires no machinery and no purchase beyond basic tools. It depends on labor, patience, and a deep familiarity with seasonal resources. For many families, this approach is the difference between a cold night and a dangerous one. Biomass may be humble fuel, but in winter it becomes essential, warming homes through the longest and hardest months. Life in North Korea shows how warmth can exist without certainty or power. When heat is scarce, floors, walls, and fabrics become lifelines. Yet this struggle is not unique. Beyond the peninsula, another cold land found its own answers. Mongolia. Curious how they face the cold in a completely different way? Watch how the Mongols heat their homes without gas or electricity and compare two paths shaped by hardship.